Good morning, children. Today we are going to begin a new chapter in geography, lesson number 3, Our Changing Earth. Students, the title of the lesson itself it indicates that our earth is subjected to change. That's why it is called our changing earth. It means earth always keep on changing its surface. In last chapter you have studied about the major domains of the earth. Students, here one of the important domains of the earth we are going to study under the part of lesson our changing earth. The major domain of earth is the lithosphere. Lithosphere is a broken into a number of plates known as the lithospheric plates. Plates does not mean here the plate where a meal is served you. Geographically, the lithospheric plate means a huge land mass. Students, you will be surprised to know that these plates move around very slowly. Always there is a slight movement of these lithospheric plate. It is ongoing process, just a few millimeters each year. That too very easily you cannot notice the movements of these plates. This is because of the movement of the molten magma inside the earth. Basically, students, the movement of this lithospheric plate is caused by the movement of the molten magma inside the earth. The molten magma inside the earth moves in a circular manner. As you know, this is always a dynamic inside the layers of the earth. Students, in order to understand how does exactly the movement of the molten magma inside the earth, let's have a small movie on the movement of a magma inside the earth for the better understanding of this movement and how does it cause for the changes to occur on the surface of earth.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart, and it's this that ultimately causes the continents to move. Where the plates collide, the rock on the seafloor containing carbon from the dead plankton is carried deep into the earth. As it descends, this layer of rock is heated, so the rock melts, releasing carbon dioxide. And gas is returned back into the atmosphere during an eruption. The remarkable cycle is complete.
On the surface of earth, of course, the earth movements are divided on the basis of different forces which causes them. Here we can understand thus The changes which occurs on the surface of earth are caused of different two movements, two factors, or you may call two forces which act in the interior of the earth. They are called endogenic forces, and the forces that work on the surface of the earth are called exogenic forces. Let us analyze these two forces in brief. Students, the forces that leads or the changes to come over the earth surface somewhere inside the earth, they are known as endogenic forces. For example, earthquake and volcanic eruptions. So these are the forces which remain active inside the earth, and they are known as endogenic forces. Then we come to the next one, that is exogenic forces. Exogenic forces are those forces which can be seen active over the surface of earth, that is outer forces. Then students, let us try to understand first the two internal forces of the earth. First one, volcano. A volcano is a vent which is called the opening in the earth crust through which a molten material erupts suddenly. Erupts means which comes out from the earth. So at the top, from here, the gases and the ash is coming out from a particular point, and that particular point on the earth is called crater. So this is what the diagram of volcano. Students, to understand better how exactly the volcano erupts and happens it, let's have a look over a small video clipping of volcanic eruptions. Similar
portals into the heart of the earth, they burn. Bottomless cauldrons fueled by an ancient wrath, bubbling and boiling thousands of miles beneath the surface and just waiting to burst through. Volcanoes are scattered across the planet. About 1,500 active volcanoes can be found across the world, though countless others are on the ocean floor. Most volcanoes, whether on land or underwater, are located where tectonic plates meet. In fact, the Ring of Fire, a path that traces the boundaries between several tectonic plates around the Pacific Ocean, contains about 75% of the planet's volcanoes. There are several types of volcanoes, primarily classified by shape and size. Major types include stratovolcanoes, which often appear as tall, steep mountains; shield volcanoes, which are flatter and dome-shaped; calderas, which are large depressions in the ground; and mid-ocean ridges, which are underwater chains of volcanic mountains. No matter their shape or size, all volcanoes emit gas and molten rock. The journey of these emissions begins deep underground in the Earth's core. The core, which can burn as hot as the surface of the sun, transfers its heat to the surrounding rocky mantle. In doing so, the heat melts some of the rock. This molten rock, or magma, is lighter than the surrounding solid rock layer, so it rises through the mantle. The magma then escapes through vents in the Earth's crust, causing volcanic eruptions. Now above ground, this magma is referred to as lava, and it can reach temperatures of over 2,000 degrees Fahrenheit. In addition to lava, volcanoes may erupt with searing hot gas formed in the mantle. In a phenomenon called pyroclastic flow, this gas, combined with hot ash, can race down the sides of a volcano as fast as 100 miles per hour, burning everything in its path. To measure and classify eruptions, scientists developed the Volcanic Explosivity Index, or VEI. It considers various factors such as the volume of lava, gas, and other emissions from the volcano, along with the height of the eruption cloud above the volcano's summit. The VEI scale begins at 0. Each successive measurement increases logarithmically, meaning that each magnitude is 10 times more powerful than the one before it. The VEI scale does not have an upper limit, but the most catastrophic eruptions measured thus far are categorized as VEI 8. These eruptions occurred thousands and millions of years ago. The most destructive volcanic eruption ever witnessed occurred in Indonesia in 1815. Mount Tambora, a large stratovolcano, erupted with a VEI measurement of 7. The blast caused earthquakes, tsunamis, and pyroclastic flows that decimated the land and took tens of thousands of Indonesian lives. The eruption even destroyed the top of Mount Tambora itself, turning the 13,000-foot tall mountain into a 3,640-foot deep caldera. While volcanoes are some of the most destructive forces of nature, they have also helped make life on Earth possible. Volcanic ash provides nutrients to nearby soil, making the land fertile. And lava, when it cools, hardens into rock and creates new landforms. With heat from the heart of the Earth, volcanoes have helped terraform the planet, making it the rich, dynamic landscape we see today.
When the lithospheric plates move, the surface of the earth vibrates. The vibration can travel all around the earth. These vibrations are called the earthquakes. The place in the crust where the movement starts is called the focus. The place on the surface above the focus is called the epicenter, means the center point of the vibration, or we call the earthquakes. And that a point of earthquake, there onwards these vibration they travels into the form of the waves around the center points, outside or outerwards from the epicenter into the form of something like a waves. Exactly, I can give an example from the epicenter, how the waves they goes on bigger and bigger, and as they become bigger and reaches to the long distance, the effect and the cause and the force of the earthquake becomes a lesser and lesser. For example, children, if you take a small stone and throw into the water body, then after this object fell into the water, so you could see over the surface of the water a round waves will be generated. And these waves initially they starts in a small size, and gradually these waves become bigger and bigger, and they cover a greater diameters. the greatest damage due to this earthquake will be closer to the epicenter, and as the waves they become bigger and bigger and cover a large area, in an extended large area the strength of the earthquake decreases and the damage also a parallel, it will be lesser than the center point of that earthquake. Children, this is how the focus of the earthquake it looks like, and the waves of the earthquake goes on increasing from the epicenter, that is the center point of the earthquake, and the plates of the boundaries will be diverted, that it is known as the seismic waves which radiate out in all the directions. So this is all about the earthquake. Students, this is enough for this class. The remaining point of the lesson to be continued in my next video. Till then, bye. Thank you.